Hey class, so today what we're going to do, we're going to solve some systems by graphing equations. So a system of equations is two or more equations that have two or more variables. So if you notice, I got a y and an x. So whenever you have two variables, that means I need two equations in order to figure out what the solution is. So our strategy for graphing is we're going to graph these two equations. Now if you notice, these are already solved for y. They need to be in slope-intercept form before we get started. So we start with slope-intercept form, y equals mx plus b. And then what I'm going to do, I'm going to graph them on my coordinate plane, and then I'm going to see where they intersect. Where they intersect, that is the solution to our set of equations. Now our solution needs to have an x, and it also needs to be a y. So that's why we have it on a coordinate plane that gives us the x and the y. So we're going to plot our first point. So we go y equals negative x plus 6. So this means our y-intercept is 6. So we're going to go up here, we're going to plot 6. 1, 2, 3, 4, 5, 6. So that is my y-intercept. And if you notice my slope, it's a negative. There's no number there, so it's implied that it's a 1. So that means I'm going to go down 1, right 1, down 1, right 1. So I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. That didn't go where it wanted. I keep following that pattern. And those lines go on forever in both directions. So that is my first line. That's the line y equals negative x plus 6. So now I want to graph my other line, which would be y equals x plus 4. So I start at my y-intercept, which is 4. So 1, 2, 3, 4. Plot that point. Now my slope is a positive 1, which means I'm going to go up 1, right 1, up 1, right 1. I'm going to go up 1, right 1, up 1, right 1. And I can keep following that pattern. So that's my line, y equals x plus 4. So what I want to do now is I want to find where they intersected. They intersected right here at this point, which is 1 is my x, and then my y is 1, 2, 3, 4, 5. So my intersection point is there, so my solution is always going to be written as an ordered pair. So my x is equal to 1, and my y is equal to 5. So that is graphing. So let's do a few more examples. Alright, so we're going to do, now this one's a little bit trickier because if you notice I've got this one in y-intercept form, but this one is not. So what I need to do first is simplify this one, solve for y so that I can graph it, and then we'll graph it, find where they intersect. So we're going to start, I need to solve for y, so that means I need to get this to the other side of my equation. So subtract 2x from both sides. So get 2y equals negative 2x plus 16. Alright, now I'm not completely done because I still have 2y there. So what I need to do is divide everything by 2. So divide that by 2, divide that by 2, and divide that by 2. Okay, so that gives me y equals negative 2 over 2 is negative 1, x plus 8. So now I have that equation solved for y, and I have this equation solved for y. So now I can graph them. Starting with my y-intercept, so this one is negative 7. So I go 1, 2, 3, 4, 5, 6, 7. So I'm going up 4, right 1. So 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Over 1. So my line looks something like that. And then I need to graph this line. So y equals negative 1x plus 8. So I go to where my y-intercept is 8. So 1, 2, 3, 4, 5, 6, 7, 8. My slope is negative 1, so I'm going down 1 over 1, down 1, right 1, down 1, right 1. And it looks like this is our intersection point. So our intersection point is 1, 2, 3. So 3 is my x. My y is 1, 2, 3, 4, 5. So my solution to this equation is 3, 5. And that is how you solve systems by graphing.